Okay. All right. So, hello. If you weren't in the Game Jam before, I'm Phil Levine. I teach all of the game design and development classes, or at least most of them, at the University of New Haven. I teach the technical ones. Um, and today, I'm going to do a little talk where I'm going to make a game in 30 minutes. I'm going to set a timer and everything. Anybody have any questions or anything before we get started? I've got a little timer. Nice to see some of my students in here.
Hello.
All right, are we all good? I don't want to take any more time. All right, I'm going to hit a timer. So, I don't really have anything planned for this. So you can see, throw out ideas as we're going along here. I'm going to do a little bit of Unity here. We're going to be working in C Sharp. And this is a totally empty project, as you can see. No special packages, just my asset inventory is here. This is a cute little thing that lets me search for things like, I don't know, grass. And I grab a bunch of grass textures because there's about 1.5 terabytes of information sitting on this computer that this tool makes it much easier to go through. So, not cheating, not in the project. So, um, everybody hearing everything okay? I'm going to just keep checking as long as everything's good.
Yes, sir. We're good.
All right. So, let's get started with some kind of example. So, I'm going to throw out a cube. Let's make it a decent size. And I'd like to be able to walk around, let's say, in first person. So for first person, I'm going to start with an empty, call it player. I'm going to throw in my usual player stuff into here. So let's grab a capsule collider. Make sure that it looks good. God, this texture is so bright. Let's make a material, clean this up a little bit. Material for the floor. I'm going to put my usual checkerboard on here and tile it out. This just makes it a little bit easier to see. Some of these materials are shockingly bright. All right, now that we can see the player, I've got a capsule collider so that we've got a little bit of collision here. I just have to turn on the grid system so I can bring this up to the height that I want it to be so that we're away from the floor. One should probably do it. Let's see. Yep, we're off the floor. And we'll need to take this main camera and put it onto the player so that it moves with. It'll also have to be raised up ever so slightly. Actually, a little high. About here. Okay, that seems like head height. We'll check it out in a minute. All right, so I want to program something real quick. Oh, error script. Okay. So I'll need two scripts at least for player controller in first person. Let's make one for player movement. And I'm going to make a second one here for camera control. So one on the player, one on the camera. We can probably start with camera. Real quick, camera control is very simple in Unity, particularly if you're not. Oh, what happened? It opened over here. That's okay. So we've got a basic script. Zoom in nicely. And let's see what we're going to need here. We're going to need an X for the rotation, and we will need a Y. And I'm going to control this via the mouse, as you might expect from any kind of first person. Let's bring start and update back. We'll probably need both. I like to delete them to keep everything cleaner. So what we would need to do in start is lock cursor to the game window, as you would. And in update, we need to get X, we'll need to get Y, or mouse Y, mouse X, and perform the rotation per frame. Locking the cursor to the game window is actually the easy part. I think it's cursor lock state equals cursor lock mode. We'll just lock it. So nice and locked. Now let's get the mouse Y. Normally you should be using the new input system, but in a game jam, there really just isn't the time. So let's set rotation X equal to input.get axis. This is the old way. The axis's name is going to be mouse Y because you reverse them in camera control. You'll be able to figure that out if you make that mistake just by being able to see it. I'm going to grab the mouse's X, and then we need to perform a rotation. Use a new Euler angles will probably be the quickest. Rotation on X takes the mouse's Y, which means this will need to be negative rotation X. Again, this will just be experimentation. They'll be inverted if you're wrong, depending on your implementation here. And then we won't need to change that. Does this look good? I could also do these in line if I wanted to, but let's keep it nice and readable and find out if that's what's going to work. This should just be the camera control. It's nice and parented. It shouldn't be able to move. Let's find out. Okay. Oop. Okay, almost there. Not quite. I can move, and I'm moving in the correct directions, but it is resetting on me. Possibly because of the cursor's locked state. Let's find out. Nope, because of the cursor. Let's do a little bit of debugging here. Rotation on X is the mouse Y. Because you don't want to set them, you want to plus equals them. This get axis is on a mouse delta, so it determines, you probably can't see me in the camera, but if you're moving your mouse left, right, up, down, you're looking at the delta, the changes in your mouse. You're not looking for the absolute value of where the mouse is at the time. Okay, so now I can move in such a, or move the camera at least in such a fashion that makes sense. Let's make sure we're not messing up our player's collider or doing anything weird. Nope, just the camera. We should probably clamp it so that we can't go upside down. But I'm not going to worry about that right now. Instead, I want to deal with movement because we're already 10 minutes in. Less time than I thought it would be. That's okay. So let's think about what we need for movement. I need a reference to the camera. I will need some kind of speed for movement. I'll need a speed multiplier. Need to know the direction of movement. And I'll also need the rigid body, which I don't think I put on. So we want to be able to use gravity. We'll also need a little bit of drag so that we slow down. Otherwise, we'll be slippery and slidey. And we're going to freeze our rotation so that this capsule just moves around the way that it is. A little bit in the floor. Let's look. 5. Okay. Now we're off the floor. Yeah, we're nice and tall. So we get to use gravity and we get to use drag, but we don't want to rotate the actual capsule because it doesn't really matter. Because our camera is going to freely rotate on the top here, we don't really care if the capsule. Okay, so we will need start as usual. And let's set that rigid body first. I always name them rig. We'll grab rig is equal to get component rigid body on the same thing. Okay, so we got the rigid body. We're going to need a couple more things. I need the transform of the camera. I can grab that because it's a child just by serializing it instead. Name is different. Camera transform. I can set this in the inspector, so I'm going to serialize this one. Let's just be speed. I'll guess and say 5 is probably enough. And this one doesn't need to be serialized. It's just speed to flyer. So I can get a sprint in here. We'll just double the speed. Movement direction will be vector 3. Movement direction, and we'll start this out as 0 just in case. Hopefully this is everything that we will need. Update on this one. Okay. So I'd like to be able to move in 4 and possibly more directions, depending on your input, which means that I need to do a couple of things. So let's start with movement. It's a game jam. I'm low on time. We'll do input get key, and this will be decode W. This feels so bad to do, but else if input get key code S. So we got forward and back. I'm going to use the else just in case. And just in case, I will also have move direction equals, actually move direction Y equals 0. So if we want to move forward, let's take the move direction Y, so our forward movement, because this is going to be just a simple WSAD. We don't need 3 vectors. We don't need Z, which would normally be our forward. We're just going to set this to 1. Also, meter is going to, if we're going to go backwards, we want to use -1. That way we have the ability to see where we want to go once we grab the camera's transform and get its forward, and we can either move forward or we can move back based on our speed. We will also need for A and D, and I'm just going to copy this and fix it. This looks terrible, and I would not put this into production, but for our purposes, this is not so bad. Do some quick changes. Okay, now we need to put it all together, which means I want to use, I'm not going to use normal translation. Let's use the rigid body. Let's add a regular force. That force needs to be in the direction of camera forward so that we're always looking where we're looking. Otherwise, it will be the absolute world value, which means we will only be able to move in these 4 directions. We want to move where we want to look. Forward is going to be modulated by our move directions Y, because we set that to W and S. And we would also like to move, so I'm going to use plus to combine 2 vector 3s here with camera right. Is that how I did this? Move direction A is -1, actually. D is 1. That puts us at W is forward, S is back, this is left, that is right. Because I'm going to use right here rather than left. And then we need to use new direction, X. And this is going to require a little bit of math. What is it mad about? Plus cannot be applied. Oh, there we go. So I want to combine all of these together. So we want to move in the direction of forward by however much we have W or S, forward or back. We want to move right based on either A, left, or D, right. Now we need the rest of the force mode, which means this is an update. So we will use force mode simple force. This means that I can make the player heavier if I want to, slow them down by using mass or more drag, but otherwise we're applying a force over time. I also wanted to multiply this by speed and speed multiplier. So all of this math, reorder operands. I didn't do this particularly carefully, but I'm going to trust that Visual Studio has my best interests at heart and trust its ability to calculate between vectors. You want to always do your vector math back on the last portion, I believe, because floats are faster to multiply. Okay. Speed multiplier is going to sit at actually 1f. So we've got speed, we've got a speed multiplier, we have a movement direction. Let's see if I've done this right first try. It's probably not right, but we'll be able to fix it. Okay. I can still look around. I move forward. I move left. I can move right. This should be a whole camera controller. 17 minutes, not bad for player movement. Let's do a quick little bit on if the sprinting, get key for key code shift. If shift is pressed, let's have speed multiplier be equal to 2f. So we double our speed. Otherwise, let's write some really, this is really terrible code. The old system of using if, keys being pressed is always terrible code. That's not my fault, promise. So we should have the ability to sprint. Let's take a quick look. I press shift, we move quicker. Otherwise, we move relatively slowly. We still slide a little bit. Let's see if I can make the sliding feel a little bit worse. That's too much drag. That feels bad. Gotta keep this at 2. Nope. No way to make this feel great. Drag of 1 is probably fine for my purposes here. Okay, so I promised a game. What do we do for a game? Any ideas for what I can do for a game? We've got our character.
Jump through hoops.
Through hoops. Oh, I can jump. Sure, let's jump. If input get key jump. Get key down, actually, on this one. Because I just want to do it once. Key code dot space. Rig, add force. We're only going to do this once because it's on down. Let's add it in an upward direction times, let's just say, I don't know. Let's serialize that so I can fix it later. Float, jump height. Let's just have it be 1 for the moment. Multiply this by jump height. And force mode is going to be impulse. We're going to use the mass, but only do it once. So the difference between impulse and force is going to be force is done in tiny increments over time. It's done per frame, whereas impulse is done all at once. All right, let's find out. So I can move. Not enough force. Oh, we are moving, but it's not enough. Jump height, let's set it to 5. Okay. Oh, I think something fell. What disappeared? No? Okay, okay. Okay, I can move, I can sprint, and I can jump infinitely, so I can fly. That's not great. Um, Actually, we can do this a little bit easier. If space is down and rig velocity y is 0. So if we are not moving either up or down, this should be enough error checking for our purposes. So I should only be able to jump. Oh, I got to change the height again. I can only jump just the once until I hit the ground. Not bad. Okay, you said through hoops? Jump through hoops. Sure. Let's make, well, okay, hoops. Trying to think of the best way to make a hoop. Normally I would grab Pro Builder and make a torus, but I can make tiny hoop like this. So it'll look like this. We'll have this be small. I'll need a material. What material should I throw onto this thing? Do I have anything good? Nothing here by default is going to be great, but I promised not to go get anything else. I'm going to try to stick to it. Let's call this little light here a hoop. And let's make a couple of them just to check. And we've got a capsule collider, which means let's do something. Let's have them make a sound, audio source. I'll just work on the one at a time. Do we have a sound? All right, I'm gonna have to grab a sound from my inventory here. Sure, we got a popping sound. So this will make a pop. We'll call it, and throw pop into our audio source. And let's make a new one. I'm gonna call it hoop on touch. I have been jumping through a lot of hoops recently, just figurative ones. Okay, we will need an audio source. I just call it AS. This will be audio source is get component audio source. I can spell today. And let's grab void on trigger enter. This can only occur once. Audio source should play. And let's destroy game object. Let's destroy ourselves. So when we are touched, let's make sure that this is a trigger. When we are touched, we destroy ourselves. Pretty big hoop. Let's change the height a little bit here. Center should be dead center. Let's have a smaller radius. Can I just stretch it in? No, I can't. Nope. Let's just bring it all the way back. This will have to do for the hoop. I guess I can use a different collider. Let's grab a mesh. Nope, wrong. Pressed enter on the wrong one. grab a mesh collider. So it's convex and a trigger, and hopefully that will work. So on trigger enter, we play. This is trigger. Let's jump into the hoop. Don't plan awake, but oh, we are slow. Why are we so slow? Jump height is 5. Let's increase the speed a little bit. There we go. Jumped through the hoop. All right, our sound is not making it. So our sound, the object is being destroyed before our sound can play because it does not wait. So on trigger, enter. Let's destroy on trigger exit. Maybe that'll be enough time for it to play the sound. It's a very short audio clip. So there we go. Nice. Not bad. 4 more minutes. What can I do? What can I do in 4 more minutes? What I would say would be if let's do it like an interact physics raycast from the camera's position in a forward direction. Out raycast hit. Max distance, let's say 5 meters. We want to interact with something. I'd like to be able to pick something up and put it down real quick. So that'll probably be useful. If the hit collider has the component, let's make an interface. I interactable. We use this interface. Hoop, there we go. I interactable. So if it has I interactable, this has to be set equal, not equal to null, because interfaces aren't implicitly nullable. And if input get button down, what is it called? No, it's get mouse button, get mouse button down. So if we are looking at something that has an interface and we click on the button, we should hit collider, get component, I interactable, and do an interact. Now we have to write the interact. Interface, interact. This is not inherit from modded behavior. So interfaces very quickly are contracts on functionality, which means that anything that implements the interface needs to also have this method, which means when we guarantee that when we look at something that has interactable and we press the mouse button, that it's going to do something because they all have interact. So what I would like to do is make a small cube, put it in front of us. Let's see if we can pick the cube up. So this will be pick upable. I've only got 1 more minute.
Feel free to keep going. This is very insightful. So as long as you want to go, you can go.
Okay. I at least want to get this done. So this will be I interactable. It's yelling at us because we haven't implemented the interface. So now we have interact. Okay. Something that needs to be picked up. What do we need to do when something needs to be picked up? I want to use a fixed joint rather than parenting it. Do I remember enough about how fixed joints work to do that? Let's find out. So I'm going to add a fixed joint. to our player. We'll need the connected body. We'll need to have a rigid body, which means box needs a rigid body. All this is fine. We'll make this little box. We'll keep it the way it is for the moment. Add a tiny amount of drag because it's a physical object. Call it box. So, pick upable. We're sending interact, which means we should send a reference to our own rigid body from player movement so that it knows what to connect to, because we have the fixed joint. Fixed joints are a little finicky. All right. I'm on extension time. Let's enable the collision on the fixed joint. The connected body. No, it should return. We should do this the other way around. This should return a reference to the object's rigid body so that the player movement, this is really player interaction and everything else in general, you should return our own rigid body and then the player can deal with it. That's more modular. Return the component rigid body. Okay, so we can interact on something that's pick upable, but now we need to do something with the rigid body. So rigid body, other's already taken, right? Is other already taken? No, I haven't used other yet. So our other, we are going to get component fixed joint. Sorry, there's a cat migrating across my desk. There you go. Thank you. Just call it connected body. It's equal to other. So we should have a connection between the two. Else, if we have an other, nope, that doesn't exist. Let's grab an overall reference to rigid body connected body. So we can use it more than once. If we have a rigid body and the mouse button is not currently down, or else if input get mouse button up for 0, connected body equals null. And we need to get component fixed joint, never write the same line of code twice, also going to be null. So that should drop the object. We'll need a reference to our own fixed joint because I don't want to write the same piece of code. Just means that we need to get it here and swap these out with joint. I haven't done this portion in quite a long time, so let's find out if this is adequate or not. Connected body is assigned, but the value is never used. I don't need to use it. Thank you for the warning, but I don't need to use it because this fixed joint should account for that. All right. Uh-oh. I'm not able to move. Still not able to move. Hold hold on. Let's see if it's something I did here or elsewhere. So I'm going to turn off the boxes in the hoop and debug and see if we're in the state that we were in before. We're not. I'm not able to move anymore. What could I have done? Let's remove the fixed joint and see if I can move. I may have messed something up here. Now I can move. Let's add a fixed joint dynamically. Well, that doesn't feel great. So if I move on the fixed joint, I just can't move at all. Yeah, you have to use fixed joints dynamically. Okay, so we have a reference to the other object, but we need to make a fixed joint. On mouse button down, if we are touching something that needs to be, we're going to make joint, equals add component. Something I'm going to have to look up real quick. Let's see. I have forgotten how to add a component at runtime. I just need to know what it's called. Add component, game object add component. Not added component. Fixed joint. Connected body. So this instead, connected body equals this. Joint is going to be equal to here. I'll still need a reference to fixed joint. Joint. It's not going to exist yet, so we're going to make one, add component fixed joint, and we will also need to destroy the fixed joint. When we're done, we should drop it by destroying the joint. Joint is equal to the component, rigid body is equal to interact, connected body is equal to body. Okay, maybe we'll be able to move this time. Need the box in front of me here. Let's give it a test. Oh, I got to move. I think the box is really heavy. Let's make the box lighter. So it doesn't move with the camera. So that would be the next thing that I'd need to do. And if I jump with it, I can jump though. So the next step would be to fix jointing this into a point in space. So I would get the end of my raycast here. So probably, a meter away from the player's face, and I would fix joint it to that instead so that it will act a little bit like this. And when we rotate, we move it up and down like that. But I'm not going to take up any more time because I am not sure that I'm going to be able to do that in a reasonable amount of time, but hopefully this has been helpful to everybody. So any questions on this incredibly rapid experiment that I've done here? Comments, questions? Anything else that you want to know how to do real quick? No, we're all good?
Yeah, I believe so.
All right.
Oh, maybe we do have some questions.
Oh,
No, I'm sorry.
At the very end. Go ahead. Anybody?
Thank you. It was
Yeah,
cool to see your
thanks.
process.
Thank you too.
Yeah,
It's
thanks.
not my usual process. That was very fast. My students can tell you we usually run into more bugs than this.
I'm students. He's right.
Yeah, especially yesterday, we ran into a lot of bugs. So, right?
I mean, what does
Uh-huh.
the process typically look like when there are a bunch of bugs?
Um, Usually a couple minutes of figuring it out. It's not usually too bad. We've never run into anything really critical in class. I'm rarely stuck for more than, even when it's really bad, I'm usually not even stuck for more than a couple of days. And if I'm stuck that long, there's probably something systemically or structurally wrong with the project. I'm thinking about it the wrong way. But most of this was real quick stuff for a game jam, so hopefully that helps whoever's working with Unity. So, yeah, any more questions? All right, seems like it's all good. I guess get back to it, huh?
Yes, sir. Thank you so much for having that presentation and going over that Unity stuff. That was very insightful. Even me, like, I've never done anything Unity before, but I have a little bit of like coding background, and just seeing some of those things come together was really awesome.
Yeah, can you send me that video and I think I'll put it up somewhere. It could be
Yeah,
useful with
absolutely.
students.
Yep, I'll do that. I'm gonna upload this to Google Drive, and then I can shoot you the link.
Okay, this has never gone so well. All right. Yeah.
All right.
Bye,
Thank you so
folks.
much.